Hello, 5th grade. This is Miss Sterner. We are doing Module 5, Lesson 16. Our objectives today, the content objective, is I can draw trapezoids based on their attributes, and the language is I can define and explain in my own words the attributes of a trapezoid. Our warm-up is an application problem. Kathy spent 3/5 of her money on a necklace and 2/3 of the remainder on a bracelet. If the bracelet cost $17, how much money did she have at first? So you'll need to draw a picture. I drew a tape diagram. I think that works very well. And solve with equations and complete an answer statement. So answer your question of how much money did she have at first in a statement. Okay, so this is a good time for you to pause the video so you can try it on your own. And then we'll come back and you can see the answer. Okay, so I'm going to show my answer. Okay, so our application problem. So Kathy spent 3/5 of her money on a necklace. So I drew a tape diagram that had 5 parts because she spent 3/5 of her money on the necklace, which we don't know how much it costs. And then she spent 2/3 of the remaining money on a bracelet, which cost $17. So I had to get these remaining 2 parts. See, that was the original line for the 2 parts. And break it into thirds for each one of them. So then I ended up having 3 parts in one and 3 parts in another. So then I had 6 parts in all. Okay, so she spent 2/3 of the remainder. So for each 2 of them is 1/3, because then you have 1, 2, 3. So she spent 2/3 on the bracelet, which cost $17. So in order to figure out how much money she had to begin with, I had to figure out which one of these parts cost. So I had $17 for these 4 parts, and I divided it. The 17 divided by 4 equals $4.25. So then I need to figure out how much money she had to begin with. So then I imagined that if I broke all of these into 3 parts each, so then 3 times 5, I would have 15 units. So then I have to multiply 15 times $4.25 so I could find out how much money she had to begin with. So I did the math here, and it equals $63.75. So Kathy had $63.75 to begin. Okay, so going back to our slides. So we have a lot of vocabulary in this lesson. So quadrilateral is a 4-sided shape. Parallel lines, lines that never intersect. You go into space forever and ever, and they're never going to cross. A trapezoid is a quadrilateral with at least 2 parallel sides. A right angle is a 90-degree angle. An obtuse angle is an angle greater than 90 degrees. A vertex is the point or corner where 2 lines meet, the outside part of the angle. Vertices, more than 1 vertex. Isosceles triangle is a triangle with 2 equal angles and 2 equal sides. Okay, so on to our lesson. We have the problem set pages from lesson 16 that we're going to be practicing with together. And then when you do your independent practice by yourself, you'll be doing work from the homework pages. Okay, so I have my math book, and we'll go to the camera. Okay, so first of all, it tells me that I need to draw a pair of parallel lines in each box, then use the parallel lines to draw a trapezoid with the following. So this one says no right angles. So you can take a break there for just a minute. Okay, sorry for that interruption. Okay, I have my ruler. I'm going to make my parallel lines, and I'm just going to use both sides of the ruler, not moving it. That way I know they're parallel. Okay, so I cannot have any right angles. So I'll just do it like this. And okay. And extend that. There we go. Erase that. Okay. So I do not have any right angles there. Okay, and then I'll draw this again. Parallel lines, and it says only one obtuse angle. So I'm going to have to make a diagonal here. And then only one obtuse angle. So I'm just going to make this right angle. Okay, erase this line here. So, okay, more parallel lines. Now it says two obtuse angles. So there's an obtuse angle. Okay. Okay, I should have labeled. Here's an obtuse angle. There you go. And here's an obtuse angle. And here's an obtuse angle. Okay. And then drawing my parallel lines again. Okay, I need at least one right angle. So you can draw this, finishing it up. You could have a rectangle. You could do another trapezoid like that. I'm just going to make a rectangle. Okay, so they said at least one right angle. Well, these are all right angles because I made a rectangle. So they're all 90 degrees. There we go. Okay, guess I was an overachiever on that one. Okay, so turning our page, it says number 2, use the trapezoids you drew to complete the tasks below. So A, measure the angles of the trapezoid with your protractor and record the measurements on the figures. Okay, so if you have a protractor, you'll need that. If you don't have a protractor, you can just watch me. And I want to show you something with the protractor before we start. Okay, so I know you've probably used a protractor before, but it's probably been a while, so just reminding you. Okay, so here we have a straight line. A straight line is 180 degrees. So if you're measuring an angle, you need to make sure the vertex, that outside part of the angle, is lined up with that circle there. Okay, so if I had this, okay, so I would have the bottom of my shape here and the corners right there, and this would be the side of my shape. So I have to start at 0 and then count up to it, and that is 60 degrees. Okay, so say I have my shape, I have the vertex, and let's make this an obtuse angle. Okay, so that's the bottom of my shape. Here's the side. I have the vertex matched up with that circle, and this says 180 on this side, but the thing is that we need to start at 0. So 180 and 0 are the same on a straight line, just depends on what you're starting at. So we're starting at 0 on this side, so then we have to go up 10, 20, 30, all the way up, and it looks like 120 degrees. So this angle right here would be 120 degrees. Okay? So, back to our regularly scheduled program. Okay. So, we're going back to, now they want us to use our protractor to measure. I have my really fast sketch from our art class with Miss Ron last week. Okay, so if you notice, 90 plus 90 is 180 degrees. 90 plus 90 is 180 degrees. Okay, and I'm not gonna measure everything, but let's see. We'll measure, you know what, it's just easier to measure this because I don't have this book in the way. So, okay, so I'm lining up my vertex with that circle. I'm lining up the bottom edge of my shape with the line here. Okay, so I am going to see, well, if I go directly, it looks like that's 122 degrees. We know this is a right angle. Okay, so we have our 90 degrees here, 90 degrees there. Okay, so again, 90 plus 90, we have 180. And then, so these two sides are also going to have to equal 180. So 122 minus 180 will be the answer for this. So we can measure it. Okay, so we line it up, our vertex, the bottom line side of our shape on the 0, and then we come over here, and we go straight up. We have to go up here, okay, because we're starting at 0, 10, 20, 30, 40, 50, and it's not quite at 60, it's 58. Okay, so 58 plus 122 is going to be 180 on that side as well. Okay, so if you have your protractor, you can go ahead and measure these two if you like. Okay, so I'm not going to do B, but if you want to, you can go ahead. So number 3, it says list the properties that are shared by all the trapezoids that you worked with today. Okay, so they have two, well, we could say at least two. This is the symbol for parallel lines. Okay, they're all quadrilaterals. It's an I. Quadrilaterals. Okay, and let's see. Quadrilaterals, well, they have 4 sides. They have at least 2 parallel lines. Can you think of anything else? Okay, well, I think that's pretty good. If you can think of something else, you can put that there. Okay. When can a quadrilateral also be called a trapezoid? Well, a quadrilateral has to have 4 straight sides. So, a trapezoid has to have 1 set of parallel lines, or 2 parallel lines. So, a quadrilateral can be called a trapezoid if it has 2 parallel lines. Okay, so if you're having fun with this, you can go on and do number 5. So you're just drawing another trapezoid, and it's giving you directions on how to do that. Okay?